Hi everyone, in this video we will solve example 3.7 from the book Applied Thermodynamics, McConkey and Eastop. Here is the statement of the example 7. A 1 kg of a perfect gas is compressed from 1.1 bar, temperature is 27 centigrade according to a law. PV to the power 1.3 is equal to constant until the pressure is 6.6 bar. Calculate the heat flow or from the cylinder wall when the gas is ethane and its molar mass is 30 kg per kilomole, which has specific heat constant which has Cp value is 2.1 kilojoule per kg Kelvin, and when the gas is argon and its molar mass is given and its Cp value is 0.052 kilojoule per kg Kelvin. In this statement, compression is taken place by polytropic process and its initial conditions of the before compression is given, and after compression the pressure is given, and you need to calculate the heat flow that is in or out from the cylinder wall. We need to calculate that. Okay, so let me write first the given data. Pressure P1, that is 1.1 bar before compression, temperature T1 and it is 27 centigrade. Convert that into Kelvin. Pressure P2 of the final state, it is 6.6 bar. Since it is polytropic process, the value of N is 1.3. You need to calculate the heat in or out during this polytropic compression process. There is two conditions also given. In first case, when there is gas, that is ethane, its molar mass is 30 kg per kilomole, and also we need to calculate the heat in or out to the process when there is argon and its molar mass is 40 kg per kilomole. In first case, the Cp value of the gas is 2.1 kilojoule per kg Kelvin, while in second case the Cp value is 0.52 kilojoule per kg Kelvin. Let me draw its PV diagram of this statement. This compression is taken place, then it is obvious that volume will be decreases and pressure will increases. But this compression follow the law PV is equal. But this compression follow the law of polytropic compressions, means to say PV the power N is equal to constant and the value of N is 1.3. This is our initial state 1. This is our final state. At final state, higher pressures will obtain and lower volume. Here the volume will be V1. At initial state, the pressure is P1, that is lower pressure, this is higher pressure. Obvious that during compression the pressure will increase, and this shaded area represent the work input during the compressions. Okay, let's come toward its solution. I hope you understand till now. We know that during polytropic process, T2 divided by T1 is equal to P2 divided by P1 to the power n minus 1 divided by n. Put the value of corresponding independent thermodynamics properties in these equations. After solving this, you will get T1, that is 300, and this ratio will give you the values of 6 to the power 0.231. This whole ratio will become equal to this, that is 1.512, and it is multiplied with 300. You will get the final T2 value, and it is 453.6 Kelvin. This is the value of T2. Now the R value of specific R constant. Now the specific gas constant R is equal to universal gas constant divided by its molar mass. Its value is 8.314 divided its molar mass, that is in the first case 30 kg. Value will become equal to 0.277 kilojoule per kg Kelvin. We are solving this for the first condition, and the gas is ethane. We also know that Cp minus Cv is equal to gas constant. The Cp value is given here. You can see, just replace this Cv and R positions. We can write that Cp minus R is equal to Cv, means to say Cv is equal to Cp minus R. What is Cp? That is 2.1 in the first case, minus R value 0.277. After solving this on calculator, you will get the Cv value, and it is 1.8 0.23 kilojoule per kg Kelvin. Next is to find the gamma value, that is equal to Cp divided by Cv. Cp is 2.1, Cv is 1.823. After solving this, you will get the gamma value, that is 1.152. Now work input in the first case is equal to R into change in temperature, that is T2 minus T1 divided by n minus 1. R value is 0.277, specific gas constant that we have determined, that is 0.277. Change in temperature, what is T2 value, that is 453. Initial temperature is 300. N is 1.3 minus 1. After solving this on calculator, you will get the work input required, that is equal to 141.8 kilojoule per kg. Next is to find the heat flow in the process, that will be equal to N minus gamma divided by gamma minus 1 times work input. After solving this, you will get Q value, that is 138.1 kilojoule per kg. This is positive, so that's why it means that in the first case, when the Q value is positive, it means that heat is supplied to the during the process. Now come toward the second condition, when the molar mass and the gas is argon and its molar mass is 40 kg and Cp value is 0.52, then the gas constant value will be equal to universal gas constant divided by its molar mass. It is give you the gas constant and it is equal to 0.208 kilojoule per kg. Also we can say that Cv is equal to Cp minus R. As you can see from this equation, Cv is equal to Cp minus R. What is Cp value? That is 0.52 in this case. R value is 0.208. After subtractions, you will get the Cv value. It is 0.312 kilojoule per kg Kelvin. Gamma value is equal to, for this case, Cp. After solving this, you will get the gamma value, that is 1.667. Now the work input that is required in this case, when the gas is argon, change in temperature T2 minus T1 divided by n minus 1. That is R value, that is 0.312. T2 value is 453.6. After solving this, you will get the work input required in case of argon, that is 106.5 kilojoule per kg Kelvin. And the value of Q, heat supplied or rejected, that is equal to n minus gamma divided by gamma minus 1 times work in. That is n value is 1.3, gamma value is 1.667 divided by 1.667 minus 1 multiply with the work value, that is 106.5. After multiplications and divisions, you will get the Q value, that is minus 58.6 kilojoule per kg. This means that in the second case, when the gas is argon and compression is taken place, heat rejections will occur. While in the first case, when the gas is ethane and compression is taken place, then heat addition is taken place. I hope you understand. If still there is any confusion, you can ask in the comment section. Please subscribe my channel if you haven't subscribed.